I think we've actually said it depends too little over the last decade, where we just use like the traditional web server-side hammer for everything. And this is where like some web apps feel the way they do. I don't think we should now overreact and rebuild everything with local first. I think we should, in the cases where it matters, build apps with local first. I think for many apps, it can totally make sense.
Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. We're really excited to have Johannes Schickling on. So, Johannes, you also have a podcast, which is the localfirst.fm. I'm a big fan of that and excited to see that grow. You also have worked on a lot of really interesting things. You helped found Prisma several years ago. You're working on a local first app called Overtone. Love to hear more about that. And then you're doing some DX work on Effect. Love to hear all about that. But before we dive in, could you tell our listeners a little bit more about yourself?
Yeah, thank you so much for having me on the podcast. I've been a big fan of this podcast for quite a while. And also the two of you have helped me start the Local First FM podcast. So thank you so much. Yeah, super excited to be here. I think over the past couple of years, I really tried to find a way back to my roots, which is building applications. I've found myself always like in this perpetual cycle of like building apps, then being frustrated about like some aspects of building those apps, and then building dev tools to make my own life and other people's lives easier. And so I've been going through like that big cycle with Prisma a couple of years ago, where I was just frustrated working with databases when it comes to building apps. Like so many things have just become so much nicer with React and Docker and all of the nice things that came about back then in serverless. But working with databases was still pretty annoying in my opinion, and particularly now that we had TypeScript back then. Back then, TypeScript wasn't really as popular as it is today, but I jumped on it early and I realized, okay, from a database, we get stuff back all the time, but it's always any. So I tried to make my own life easier back then, and that led to Prisma. And in 2020, I had a nice opportunity to take a sabbatical and use that time to also get my own hands dirty again, to start working on some different app ideas. And I've decided to keep going in that chapter. And right now I'm kind of like living my sort of polyamorous work life, where I put my nose into a couple of different projects at the same time. And so that has led to me working on Overtone, the local first music app, also working on like some data stack that can be used for local first apps. And I've also found out about Effect quite a while ago. And so I'm also trying to have a positive impact there and involved in a few other projects. And so that gives me a really nice holistic perspective on app development in 2024.
Yeah, that's exciting. You're definitely got a lot of balls in the air. So when you were working on Prisma, did it start off as just like, I'm building an open source tool to solve a pain point that I'm having, and then it evolved into a company? Or did you go into it like, no, I'm going to build a company around this problem? Like, what was your thinking when you first approached it?
Yeah, I think that's a great question. And I would actually encourage more first-time founders to think more critically about separating out the technology and the problem you're trying to solve, as well as like, is the best way to do that as a company or not? So back in, I think, end of 2015, early 2016, I was just, I just had sold my previous company, which was like a VR app. Like we tried to build like a Instagram for VR way back then, when like VR was like very, very early. This was like when you had like Google Cardboards and so on. And I was still annoyed with like how much time it took to build the non-essential parts for the app, like the backend, etc. I tried out like Firebase and Parse, etc. And I liked the velocity, but it was just so limited that I felt, okay, there had to be a better way to build apps more quickly. And GraphQL just came out and serverless just came out. And I tried to combine those pieces, and that led to a thing that was called GraphCool back then, kind of like a pun on GraphQL. And so that's what we went with for the first couple of years. But then we also realized, okay, people love this to build MVPs, but not really to build production grade apps. And that has then over time led to a pivot to Prisma, where we focused a bit more the scope on just the database tooling and leaving the rest of the backend bits to the actual app developers. I think that was the right call, even though people seem to really like GraphQL and we put a lot of love into it. But that was the right thing to do for us to be more focused. And the entire thing grew then also from an initial project that was bootstrapped to having raised some VC money for it. And I'm still on the board of Prisma, but the folks there are now still doing the day-to-day work. But I'm excited about it.
Before we move on to talk about Effect, one question that's just like really interesting to me is when did you sort of decide that to take a sabbatical? Is like, what was that kind of point for you? I mean, I had went through sort of a big burnout phase during the pandemic and quit my job and went to Recurse Center, and sort of that was my sabbatical. But like, what's your story there?
Yeah, I mean, of course, yeah. I was the founder and CEO and like led the company there for like close to 5 years. And if you've founded your own startup, and particularly when raising VC money, etc., like it's just nonstop. This would be. I don't want to get into like the work hours, but it was a lot, and it didn't really leave time for anything else. And at some point, just like while walking home in the nights, I was kind of like thinking back, oh, like my life was like had quite a lot more facets in the past. Like, it was DJing, I was doing skateboarding, I was doing all sorts of other stuff. And at that point, my life was really just like reduced to just Prisma, which fulfilled me quite a lot. But I also did miss those other pieces. And I also just wanted to like have a bit more balance again for other parts of my life. And so that was always there in the background, but there was no opportunity yet to do that. And then in 2020, we just hired some more senior leadership folks. And this was the first time where I could really take a step back without everything falling apart. And I could take that opportunity, and I'm very grateful for it.
Nice, awesome.
Cool. So with that behind us, the rest of the episode we'll talk about the things that you are building since leaving your leadership position. The first thing is this effect library. So I tried to look over the docs. It's pretty complicated. It's a much different style of programming than I'm used to doing, at least. So could you explain to us and our audience what effect is and why I might want to use it?
Yeah, totally. Maybe the best motivation for me is like why I even like was looking for something like effect and was then ultimately finding it. So while Prisma, I just saw like many TypeScript apps being built by tons of different engineering teams, etc. And like we tried to make some aspects of that better with Prisma, but there was still like so many other problems that I just saw in like every production app. And I'm sure like you've experienced those problems also yourself quite a lot, whether it's like error handling, whatever it really means to build a production grade app. A lot of it is error handling, but it's also about making your app faster. If you want to run code concurrently, sure, you can do promise.all, but what if one of those things goes wrong? Like, how do you just let everything explode? Or if you like do a lot of stuff and then maybe in your front end app you send off like 50 fetch requests and you navigate to a different site, do you still want those 50 fetch requests to happen in the background? So you want to actually cancel them with a board controller. And all like doing the right thing is not easy in TypeScript. And that has always bothered me. And doing the right thing is a lot easier in other programming languages, such as like Rust or Golang. They had sort of the benefit of having seen like other programming languages maybe get it wrong or right and be inspired, or like try to draw some lessons from that. But TypeScript and JavaScript is kind of stuck with the past design decisions. And I try to really explore, okay, maybe I should reinvest my energy into going all in on Rust. And I did like some Haskell in the past, etc. So I knew there were better ways, or Swift was also really nice in the past. But I ultimately came back to, okay, JavaScript is just here to stay. We're probably going to go to space at some point with JavaScript. So maybe we can bring some of those learnings into TypeScript. And this is where I basically was arriving at like I had found some really nice patterns in other programming languages, and I was looking for folks who try to already apply them in TypeScript. And so that has initially led me a bit more towards functional programming. But even though those are the right ideas, I don't think we can't expect like the entire TypeScript world to just convert to functional programmers. However, I do think in sort of like a Trojan horse way, it can be done. And I think the best example for that is like React and Redux, etc. Those are just like all functional programming paradigms. But you're not like very loud about like, oh, React is functional programming, but you rather use those patterns. You try to make them really nice and simple to understand, and then you make the right thing easy. And so that has led me to find this TypeScript ecosystem called Effect, which had so many of those great ideas and packaged them nicely for TypeScript. So it's still quite a bit to get into initially, but I think the learning curve is getting a lot better. And so now with that motivation for like Effect helping you to build production grade TypeScript apps, you can think a bit about it like a standard library for TypeScript that helps you with building production grade TypeScript apps. So in the same ways, like React has made building front-end apps a lot better by giving you solid primitives such as components and hooks, etc. Effect kind of gives you the same thing, but almost like for the complementary part to React, like wherever you build wherever you have an async function, wherever like an arrow might be thrown, etc. So it gives you those better primitives that you can build your app around. And that has helped me a ton, and I've been using it for every app I've been building since.
Just for clarity's sake, what's your actual affiliation with Effect? Because you weren't the creator of the library, right? You're just like helping out with the DX, or what's?
Yeah, exactly. So I found out about this project like in 2020, and I was really, this was a big decision for me. So should I like bet my time investment into this like TypeScript ecosystem that seemed really expansive, but very few people have heard about it? And so I got in touch with the person behind it, Michael Analdi, who's like a brilliant engineer from Italy. And so step by step, I got to know him better, got to know the project better, and became friends with him. And over time, I just found myself spending a lot of time on it. And eventually, Michael was also like quitting his job and putting more time into Effect. And so this is where, like in a small capacity, started to help out. And now there's a company behind it, which does pay me on a part-time basis, where I'm trying to help out a bit. So we've just put together the first Effect conference where I've given the keynote. I'm just trying to, like, with some limited time, try to have a positive impact on the Effect ecosystem, and by making it easier to understand. And so the website is like a first big step there.
We'd like to thank our sponsor for the week, CodeCrafters. CodeCrafters makes programming challenges for experienced software engineers. If you're looking for a weekend project that takes you to the edge of your programming abilities and really puts you right back in that seat in college where you're figuring out binary formats, you gotta check them out. They have a bunch of really cool challenges to help build your skills while also building popular open source developer tools. So they have things like build your own Git, build your own Docker, build your own SQLite. The cool thing about this is you can go through these challenges in any programming language that you want. They have things like Rust, Go, and JavaScript. But in my opinion, if you're not experienced with that programming language, you should try to stick to what you know, because these challenges are actually pretty challenging. I've personally gone through a bunch of the challenges now, but this week I started to try the SQLite challenge, and boy, once again, and I'm surprised at the complexity of it. Most of these modern tools are fueled by a file that has a binary format that you have to learn to reason about its mechanics. It's much different than just console logging an object in JavaScript. Besides the content, even the user experience is targeted towards experienced software developers. For example, you don't code in their website, you code in your IDE in your terminal, and all you have to do is push up to CodeCrafters, they run the tests, and they tell you if you passed. Pretty cool if you ask me. To try out CodeCrafters for yourself, visit codecrafters.io/devtools-fm. There you'll get a 40% discount, and you'll also be helping out the podcast a little bit. If you want to find another way to help the podcast out, you can become a member on one of the channels that we provide it, or you can head over to our shop at shop.devtools.fm and buy some of our merch. And with that, let's get back to the episode. So all of that sounds great, but what are some of the primitives that Effect gives you to make all of this possible and make all of this easy?
Yeah, so Effect gives you a set of primitives, and we could go into them in sequence, but we don't have enough time because it's really the same ways. If you think about it, like the Rust ecosystem or the Rust standard library, there's so much good stuff there. So you should really put your eyes on the stuff that's relevant for your use case and for the app you're trying to build. But I can I can touch on a couple of components or primitives that are very common for most apps. So I think the most common one is called an effect. That's also where the name comes from, but that's also based on some academic research that happened over the last couple of years, maybe decades, around the ideas of an effect system. A very lightweight version is also seen in React itself, where you have use effect, but that's a very, very lightweight version of it. But what you can already see in React's use effect is that it can run some code that can do some unpredictable stuff, but you also get a callback that gets called when you unmount the component. So that already sheds some light on some aspects of where effect goes further compared to, let's say, a promise or an async function. A promise, you basically just say okay, that's happening now, but the ship has sailed and you have no further control over it. So you have no way to really interrupt the thing unless you use an abort controller, which is really annoying to work with. Or you can't really tell the promise further to pause for a moment or resume it later. You have no knowledge about, on a type safe level, for example, what might go wrong with a promise. So think about an effect, basically a Superman version of a promise that is just much more thoughtfully designed, that you can retry if it fails. You know which kind of, on a type safe level, you know what it can fail with. You can interrupt it, you can suspend it, you can resume it. And given that it's more of a description of your function, you can also retry if it has gone wrong. You can think much more easily about it in terms of concurrency. So it's quite low level, more about how you would rethink of how a language treats some execution parts a bit differently, or in the same way as React also has an implementation detail of the fiber system, which makes all of the good stuff happen. Effect also has a fiber system to run all of that. But what you get is then, once you're rewired your brain a little bit to think in terms of effect, similar how you've rewired your brain in the past to think about React components, then it unlocks all of that good stuff like composability, testability, much better type safety, making it much easier to build fast code, etc. So yeah, to come back to your question, effects are the most common primitive, but there's lots of other ones that are really useful for example, streams, which you might know from RxJS. Effect has a full replacement for that. What's really nice about that is with RxJS, either use the RxJS hammer for everything, even though for things that don't want to be streams. But I think that also can have some downsides. In effect, you really have a very nicely fitting primitive for each situation that you're in, where the API is the same, etc. And you don't have to bend over backwards to use your favorite tool in a setup that's really not useful. And so that's what makes it really nice.
I have a lot of feelings. So, I mean, I ran into the problems that Effect is sort of built for really early on, and I've done a lot of work across a bunch of different programming languages. Rust is something I've been working on really heavily for the last several years. So, and I've complained about this on Twitter. So the lack of a proper enum or variant type or whatever is something that really bothers me in TypeScript. So TypeScript has an enum, but in languages that have first class support for enums, they give really good like pattern matching, usually with that enum that like helps you. And usually when you're constructing an error, it's like you have these like explicit tagged error cases, and you can sort of, go through and match against different failure modes and do some interactivity. And like effect gives you that, but there's this layer of complexity that gets like added on top, because I see it as sort of almost fixing some of the failures of the language itself. Like the language doesn't do certain things well. So I mean, just like an example is like promises and async await. So if you like await a promise and you don't, and it could potentially throw, and you don't handle that by wrapping in a try statement, then that could throw, that can make your calling function throw, and you might not want that to happen. But it's it's like easy to do the thing that will work, but hard to do the thing that, to do proper error checking. And I can see effects being there. But I guess I'm struggling with this. Is like, I was going through the docs, and, a lot of these things are given if we had just like a better language. Not that I'm hating on TypeScript, because I really like it, but like, I think of like Rescript or Gleam now, like these more proper functional languages that actually give you like Rust type monads and like things that you can use for error handling or whatever. How do you sort of balance like the complexity that you're solving with the complexity that you have to implement and add to sort of do these things when it's, some of the problems that you're fixing are kind of language deficiencies, or like just not deficiencies, but like things that TypeScript can't do because of some of its constraints?
Yeah. So I think you're touching on a couple of really good points. And I was really at that fork in the road where I was thinking, maybe I should like pick one of those programming languages. Are they going to take over the world? No, but I'm smart enough. I can learn them. But then I also realized like I'm not working on stuff just by myself. I collaborate with others. And there's a lot to be said just for a powerful ecosystem. And I think the two big ones there right now, I think, are Rust and I think most importantly JavaScript and TypeScript. And there's just so much optimization work that's going into browsers and other JavaScript runtimes. And for me, ultimately came down to that in Rust, you still need to deal with memory management. And for most apps, that is really like a toll or that I'm not willing to pay for most apps. And now it's about like bringing those right patterns to TypeScript. And turns out that TypeScript is just magnificently flexible and ergonomic if you just impose the right patterns on top of it. And so one thing that we're doing with Effect is basically ignore some of the syntactical affordances that TypeScript has, and just embrace a couple of other patterns. So very importantly, instead of trying to do try catch for your error handling, we rather treat errors as results. And so that's a common pattern in Go or in Rust, that instead of just like throwing somewhere, we basically don't throw, but we just say like, okay, this is not as we expected. And then instead of just returning the expected result, expected value, we just return like a tuple or like an ADT or something like that. So that's what, or like an enum, what you alluded to. And so that you can perfectly do already in TypeScript. And once you follow those patterns, your code actually becomes, you need to rewire your brain a little bit, but then your code becomes a lot simpler. And you no longer need that try catch. That gives you type safety basically automatically. And Effect has basically just picked up this pattern and makes it really, really nice to work with that. One of the coolest things about the Effect type specifically is like, think about it like a promise, where a promise has one type generic, that's the result value of it. But an effect has the same, but it has two extra type generics as well. So the first one is for the normal result value. Let's say you have like a thing that returns you a user in the success case, so it's like an effect over a user. But the second type parameter could, for example, be like a user auth error. So that's for errors. Those are the errors that could happen, that you want further up in your app. You want kind of check, or possibly like errors that can happen on the backend that you even want to send over to the front end and deal with there. So that's super useful. And then there's a third type parameter, which is for the context. So think about that as React context, where like somewhere as you compose your components, very much outside, you say like, okay, here's like, I have like those config values, or in a backend context, you might say like, this is where I have my database connection. And you don't want to thread it carefully through each arguments through all the function calls. So you can just have a context, and the stuff deeper in your program says like, oh, I need a database connection. And then as you compose your code, as you reach the top and you want to run your program, now effect will tell you, oh, you can't run the program yet. You first need to provide that database connection. And that makes it so powerful, that composability, since that is not just, it can't just make sure that you provide a database connection. Itself can also make sure to like initialize the database connection when the program ends. It closes the database connection. So it handles so many of those like production grade problems that are really hard with normal TypeScript, and makes those really easy.
Yeah, these concepts feel like I'm going to leave this episode and it's going to be like the X state episode, or one of those episodes where I'm like, oh, I got to sit with this and like really come to terms with it. So when I'm building programs in effect, do I have to like go bottom up? Like, do I have to start with like my most primitive values and be like, okay, this can return a value, this can return an error, and then work my way up into an effect program? Or can I go the opposite way too, where I'm like, okay, I have a lot of code already and I just want to start utilizing effect where it can start making my life easier and work my way down?
I love that question. That's fantastic. I think that basically speaks to how incrementally can effect be adopted. And I want to contrast that to adopting a different programming language, which typically is like all or nothing, big bang migration. And with effect, you can very incrementally adopt it. So you can adopt it in a single file, in a single line. And you can also, like, if you think about your big program as a tree, you can do it at the leaves, you can do it at subnodes, you can do it at the root. You could do it in multiple places at the same time. So there's very smooth interop between like effect code and non-effect code, much easier than with like React. There's typically like React wants to be everything, and once you have like a non-React thing and a component gets kind of fiddly. But with effect is like you can go from a promise into an effect, from an effect into a promise, or like non-asynchronous code very, very easily. So you can adopt it wherever you see most fit. I do think that one of the best ways to adopt effect is by not building net new code, which you can also do. But I do think effect is really nice to adopt as you want to refactor your code to make something better. So maybe you have your code, it works mostly, but you know, like, oh, damn it, we need better error handling here. And so you have a couple of throws, whatever. So you rewrite that code with effect. It will have the same or less lines of code, but afterwards you have your async await signature. You get rid of that, and you have the effect equivalent. But now you also have type safety for your errors, or whatever use case you have. Refactoring is a great way to already have a before and after that can be rewarding, and you can get there very quickly. Another huge point that effect provides, which I think is just getting a bit more mindshare, is observability. So I think most JavaScript developers are maybe not quite familiar with the term observability. And once they sort of learn about it, they think, oh, that's like my console log, right? So the idea is basically to know what is going on with my program as I maybe run it locally or as I run it in production. When you run it locally, either the app just like works as intended, and hopefully it really does. But if you want to rather look into it, like what has happened, maybe you start adding a ton of logs into the execution, but that can get out of hand very, very quickly. And so it turns out there's a much better approach to this, and that's broadly summarized under this term of like observability, where you don't just have logs. You do have logs, but you also have metrics, and you have, most importantly, in my opinion, you have traces. And those traces give you a very visual representation of what is going on in your program. And so that's something that's very normal in Rust or in Golang and other programming languages. In JavaScript, I think it's it's done less often, but more and more people do realize, okay, we really need this. But instrumenting your code to be observable, for example, with a technology standard called OpenTelemetry, is really, really tricky. And that's another thing that Effect gives you out of the box. Effect has like built-in tracing support for like every part of your program. And that's another superpower you just get for free.
Yeah, observability instrumentation is a challenge, and I mean it's a challenge in part because it's like easy to miss stuff if you're manually instrumenting it. So I could see how if you're doing your side effects with Effect and that gave you instrumentation out of the box, where that could be very, very valuable. One more question on this topic before we move on and start talking local first. One of the things that I noticed is going through the docs is there are two different patterns of using effects. So one of the big values of the effects library is that you can compose like multiple effects together in sort of this larger chain, this larger effect. And you can either use this pipe function, which if anybody's used something like Ramda.js or like some other functional programming library, these pipe functions like chain or compose a series of functions, or in this case, effects together, or in Effects case, you can use a generator. And the docs kind of like you can kind of select, choose your own adventure, and then at some point, like it sort of starts defaulting to generators. And just curious about like why those two different approaches. And I mean, do you have thoughts on which one is more preferable, and why, and etc.
Yeah. So Effect had its beginnings very much in the functional programming community, where you do try to express everything sort of like those pipes. Over time, we realized that there's no reason why we shouldn't try to make Effect more accessible to non-functional programmers. And so we tried. That has gone in a couple of chapters, and we've renamed a ton of stuff that was previously like very functional programming heavy to leave that entirely behind. So if there's like some residue that feels very much like functional programming, that's a bug, and we want to address that. In the same way as like React, people shouldn't be afraid of like adopting React because they feel like, oh, but like I don't want functional programming. So, and that syntax in terms of pipes and generators, that is maybe still like the most visible aspect of it. But it has, so that's a bit of the historic context. However, more looking forward, the idea of like using a generator here is very similar to async await. So I'm not sure when most listeners have really started to go deep on JavaScript and TypeScript. Back when I started, there was like callbacks was the only way how I could write asynchronous JavaScript. And it turns out that's still the fastest way to write JavaScript. For like nitty gritty details we don't need to go into now. But at some point, promises became a thing, generators became a thing, and then also async await became a thing. And I think right now, most people use async await because it gives you quite a lot of convenience, except from the pieces that we've talked about with try catch, etc. But the mental model, I think, for async await is really nice. That you basically, you can just write some code and like, okay, that thing is asynchronous, so I await it. And that's really nice. And generators basically give you the same mental model the way how Effect has started implementing it. So instead of like asking someone to think about everything as a functional programmer, that's possible. And if someone wants to do that, go for it. But the power of Effect is that you don't need to know that. You can just write your code pretty much like you did before with where you've used async await. You just now use generators for that. We even considered to have like our own like JSX like equivalent. When React started, there was like a similar problem where they try to make it easier to use to write React apps. And so they made back then the controversial decision to create JSX to just like have a better DSL for that programming environment. And so we considered doing that as well, but we didn't want to. We're not Facebook. We don't have like the same sort of resources, and like we can't just go to the TypeScript team and say like, hey, here's like the DSL we'd want you to ship to everyone. So we try to just like embed that into TypeScript as it is today, and that's where generators are actually super powerful. And the type inference capabilities of generators are just incredible. And I think they're heavily underused. And actually, I'm seeing it more and more being used now. So I think generators might have quite a bit of a comeback over the next couple of years. But this gives you basically the same mental model as async await, but with better type inference. So if anywhere in your generator code you are running an effect that could throw or that could fail with a user auth error, then the effect that is like the generator body, like your async function body, now infers not just like, oh, this returns a user, but automatically infers like, oh, that could have a database error or that could have a user error. And that is just something that this unlocks. So you don't need to change the way how you think about building your app. If you write a lot of like async await code before, you can literally like just search replace that to the effect generator, and it should just work.
Interesting. That I definitely need to sit with it, but I feel like I'm starting to understand. So like the underscore basically gives you programmatic access to kind of to like the pipe that's happening. Like, can I look at those as like the same thing basically?
Yeah. So if the listeners want to like look at the website or the docs, the generator has generators in TypeScript have or JavaScript have like a little bit of a cumbersome syntax, but you're getting used to it quite quickly. And the way how you then the equivalent of an await with generators is a yield. There is like the underscore that you referenced here. That is technically not necessary to run the code, but that is unfortunately still necessary for the type inference to work. And so this is hopefully at some point we can just drop it. There is a PR open to the TypeScript repo, which would make that happen. But that right now is just like, we call it an adapter, but it's really just like a wrapper. And that also gives you pipeline abilities. There is like another case where pipes can be quite useful, is like, for example, for error handling. And so there is like, you can sort of have a hybrid way of writing it. And after you've done it like once or twice, it starts feeling natural very quickly. But yeah, I wouldn't expect listeners to walk away from this podcast that like, oh my gosh, like I know everything about effect and now I just naturally write my apps in effect. Hopefully you become curious about it, that you learn it like in some small steps, become a little bit more comfortable writing in that style. But I think most people really who are getting started become comfortable writing in this way after like a day or so.
Cool. So switching gears, the other thing you've been focused on a lot is local first. You have a new podcast called Local First FM, and you also have a conference that you're throwing in May. So congratulations for that. That seems like a pretty cool big step. So what aspects of local first dev get you excited? And like, what are some cool local first apps you can point to as like, oh, that's something to shoot for?
Yeah. So, I mean, turns out all of us are probably using ton of local first apps already on a daily basis. If you're in the Apple ecosystem, most Apple apps are actually local first. This is why I pull out like the Apple Notes app by default. If like someone tells me something interesting, I don't trust Notion to open quickly enough or like to still remember my data later if I'm like in an elevator or something. But the Apple Notes app, I can pull out and like immediately write down a note and it's going to be there. And the reason why it's so fast and reliable is because that's local first software. And also a couple of other apps that I think are by now much more popular, whether it's being linear app or something like Superhuman, etc. They're all like local first inspired. Local first the term came out of a research lab called Ink and Switch. And I'm friends with some folks there for quite a couple of years by now. For example, Peter van Hardenberg, he's also been an advisor to Prisma in the past. And so this is where I got some closer looks on the evolution of local first as it's been brewing. And then the paper or the essay was released in 2019. And this also was just the right time for my sabbatical to take a closer look at that. And it took a little bit of time, but then it really all started to click for me. And it made so much sense that this is like maybe a bit more of a radical change, but really a change that addresses so many problems that we have, both in terms of building apps, but also that we as software consumers, but also software creators, where we've just like fallen down like one path that is not necessarily in the best interests of app developers, not in the best interests of consumers, and sometimes also not in the best interest of companies. And so a lot of the software we build and use right now is like heavily skewed to satisfy the needs of an AWS, but not necessarily of the other participants.
So you're working on a program called Overtone, which is a local first app. Could you tell us a little bit about that?
Yeah. So Overtone was the desire to build Overtone has really thrown me down the rabbit hole of myself building local first software and really discovering for myself like the different principles. So for the listeners who probably have no idea what Overtone is, with Overtone, I'm trying to build a new kind of music app, maybe more specifically a new kind of music client. um, I'm I love that we have like in some aspects of software we have like very rich freedom to choose like our favorite tools. So whether that, like, I think the best example for that are email clients. You can have your email server wherever you want, whether it's Google Mail for most people, but if you want to, you can host your own, etc. And so you can choose wherever you want to have your emails, and you can choose your favorite client. I think in the past it was even more common to have different clients for different things. But for example, I'm also using a chat app called Beeper, or a chat client, where I can add like Twitter and Facebook Messenger and WhatsApp and Signal all within one app. And it's always bothered me that music for me is like as scattered across different platforms. I have a ton of music on YouTube. I have a ton of music on Spotify and Bandcamp, some of my own music on Dropbox. And I have like tons of tabs open, or like tons of different apps for that. It's always bothered me. Why do I have like all of those different apps? Some of them are really not that great. And I was like longing for having a unified experience around that, as I have with an email client. So that led me to, after punting on this idea for quite a while, to eventually think once again in my life, how hard could it be, and starting to work on that. But then it also dawned on me, okay, the how would I even build that? I don't want to compete directly with Spotify. I want to have a client that integrates with those different platforms. But I didn't want to have like, if that app is successful, I didn't want to have by default that to be a VC style backed company. So one direct implication of that is that I wanted to have it be as little dependent on the cloud as possible, on my own cloud as possible. And that really made me interested in local first, and where I could connect the dots a little bit more. So I want to build Overtone in a way where I don't run any of my own servers, where you just have a very capable client, and that client connects to wherever your music lives. So that connects to Spotify, that connects to Bandcamp, to YouTube, to your Dropbox, etc. And that's how software worked for many, many years. And there's nothing wrong with that. In fact, it just makes for better and faster software in many cases. And so that was a reason why I combined those ambitions for this music app with seeing that as a good excuse to get really deep on local first software. And so the ideas for this here is with one major caveat. With local first, you try to have like all of your data locally. I can't just suck down the entire Spotify catalog to have that locally. But what I can do is like I can make the music metadata that is relevant for you. I can make that available for you. So like for your playlist, for the artists you follow, etc. And turns out for really using the app, the metadata is like all you need. And then you can stream music if you have internet connectivity, or you can pre-download tracks if the platform allows that, or if it's music that's coming from your own Dropbox, etc. I can also make that available offline. But besides that, it can work fully offline. And that's also like, I think local first is sometimes confused with the term offline first. It's really a lot more than offline first. Offline first is an aspect of it, but a lot of people think about offline first as like, oh, like I have my app, maybe it's a Next.js app. Now I want to make it offline first. I'll just slap a lot of caching on top of it, and then fingers crossed that it works. But that really starts to break down very quickly with like, what about doing writes in the meanwhile? Well, I guess we can do optimistic writes, but what if you go online, etc.? So you really can't like retrofit something like offline first on top. And this is where local first goes one step further. It says like, hey, we don't just have offline first, but we also want those apps to be collaborative. That's another big thing that I think the cloud unlocks and that we really take as table stakes by now. So for example, the script is collaborative by default. And making apps work offline collaborative is, from a technological perspective, actually a very similar problem. And this is where local first goes way beyond offline first, and also has a couple of more ideals that ideally users should also own their data, that if apps are being built this way, it can actually help with the longevity of software. It's kind of funny that like software that was built for MS-DOS or like that era, that software still reliably works today. But I think Google just shut down like Google Podcasts, or like I'm still nostalgic about Google Reader, etc. Like all of that software where like they've poured like millions into building this, or Google Inbox, all of those tools like we can no longer use. If they're, and that's because like by default, like it can be turned off. That means like the service, the cloud is turned off, but you can't turn off like the MS-DOS software from back in the days that worked very reliably. And so with local first, if you just flip that around a bit, if you change the responsibility of the cloud for rather enhancing your software as opposed for being the absolute foundation, I think there's a lot of interesting implications from that. Right now, like most web apps are really like more like the mighty browser tried to do at some point. There's like some server rendered stuff, and you might just as well have like a remote rendered screen that you're using. And like it's the app after the server goes down or you lose your connectivity, the app is like as useless as like a remote rendered video of the app. Whereas with local first, it's like the app is useful by default always, and it's just enhanced through connectivity that you have. Like we're online, we can in real time collaborate, or like I'm online, I can back up my stuff, I can pull down new stuff. But it's kind of weird that we're just so accepting and used to software not working when we don't have perfect connectivity. And just flipping that's a major aspect of local first.
Yeah. You've covered a lot here, and like local first is a really exciting technology, and it seems like it's getting a groundswell, especially right now. But I mean, some of these problems are not easy problems to solve. I mean, it's talking about like, okay, you want like a rich client experience, you want it to sync. Most of the time it's like local first, not local only. So it's like syncing to some cloud services, syncing to other clients. Non-trivial problems. So just in your own experience of doing these implementations, what are some of the challenges that you've faced when trying to build local first apps?
Yeah. So I will say that there's you can look at those problems from two different perspectives. I think there's the perspective of like a couple of years ago when I started, or today, of like what are the problems that still exist today. And a lot of those will not exist in like a couple of years from now. They will be like very smooth, similar to how it's easy right now to build a Next.js app and deploy it in Vercel. You don't quite get the same experience with local first apps right now, just because there is no well-trodden path yet. There's no Rails for local first yet, but those things are being created. And then the second aspect to those problems is like, what are just like inherent problems that need to be solved that are just inherent to that architecture? And I'm very bullish on the latter. I actually think that local first has the potential to really just like eliminate a whole category of problems that we are right now needing to deal with. A lot of it are distributed systems problems. I think this is like a bit of like the elephant in the room for most web apps are distributed systems problems, but no one is talking about them, and very few engineers have the background to even acknowledge that those are the problems that we're fighting. A lot of like caching, etc., are kind of like sometimes red herrings, and really should be thought about differently from like an architecture that fits the app's use case well. And this is where I think local first can be a really interesting starting point that avoids a ton of accidental complexity. And right now we're just like building tools and systems that help fight complexity, but while we're just introducing more accidental complexity. And this is where I think local first can really massively reduce the overall complexity by eliminating accidental complexity. So that was like a whole bunch of like more abstract thoughts on this, but more practically, right now there's actually a couple of really interesting stacks already to start build your own local first apps. I think we'll have to see in a couple of years from now which ones of those will be the bigger winners and which ones remain a bit more niche. But I think there's a couple of really interesting options already. So I will call out a few, for example. So there is like Replicache by a company called Rosie Corp. I think they have a pretty mature offering by now that allows you to build like a syncing-based system already. There is also a company called Electric, which I'm helping out. So what's interesting about them is that they build everything on top of Postgres. So if you already have an existing Postgres server and you want to, let's say, like add a local first app to your stack or enhance your app to be more local first, then they make that really easy. If you want to keep using that SQLite database, that Postgres database, and for example, use SQLite on the client. I'm already teasing SQLite. There's like also a lot of SQLite based options, whether it's like Torso, which brings SQLite more to the edge and possibly to the client. I don't think has like a ready-made option yet for local first, but is pointing a bit in this direction. So I think there's already quite a couple of really interesting options that you should shop around a little bit and see what feels best for your app use case. And the cool thing about local first is like that building your first app can really be done. Like it can be as quick as with Firebase. It's just that you need to pioneer a little bit for taking it into production. And one last one I'll also shout out is Automerge by the folks at Ink and Switch, which is like probably the most mature CRDT implementation right now. And CRDTs, we probably don't have enough time to really go into that right now, but that's the most meaningful foundation to build those data synchronization frameworks.
Yeah, lots of exciting stuff happening right now in the space for sure. So from our conversation, it seems like you've typically been like more on the back end of things in your career, but with your Overtone app, you are doing full stack. So you're doing everything from the front end to the back end. And with that, you've been using React a lot. And you told me before the interview that you might have some interesting things to say about React and have a unique perspective. So what is that perspective?
So hopefully not overselling here, but maybe a different perspective than a lot of React developers that I've noticed over time. So I think one thing that I've already seen for Overtone, and also like I'm building a state management thing for Overtone. Think about it like a bit like Redux or MobX, but with local first in mind, and is actually based on SQLite. And this has a couple of like strong opinions how it started, and I think those opinions are now also seem to be also adopted by a few other more forward-looking technological systems. So one of it is that you try to pull out your state outside of React, and I think this is where like some people are like very confused about that, and it's like obviously we should have like all of our state in React use state. That's what it's for, no? But I'm coming to the conclusion that it's actually a lot easier to move your state as much as possible outside of React. And just in some cases where you really never need that state to be not in React, you keep it there. But by default, keep your state outside. Have it be managed outside, and have it be managed similar to like a DAG. And I think that's also kind of similar to what people do with signals. And this is where by not solving some problems, you sidestep a lot of really nasty React problems, where you try to synchronize state with React use state, and like it causes re-renders, etc. That's another accidental distributed system in a single thread in your main thread in your web app. And just by like handling all of that state outside of React, letting React do less, you'll get a simpler app, you get a faster app with less re-renders overall. So I think that's like one take I have, is like do less in React, move state management outside of React when possible. And that's what I'm exploring for Overtone as part of a project called LiveStore, which was previously developed with a friend of mine, Jeffrey Litt, as a MIT PhD project under the name called Riffle. We can also put it in the show notes. And that was sort of like a really interesting research project that brought the idea of like, hey, SQLite can now run in the browser through in WASM. Could we go a step further here and replace something like MobX or Redux with a reactive SQLite-based state management system? And that has been like one of the most foundational technologies that I'm using for Overtone, that without that wouldn't be possible. And like one really nice benefit of that as well, given that all of your state now lives outside, it can, and like lives inside of SQLite, you can also very easily persist all of that data. And that gives you like some aspects of software that I think we've kind of forgotten how nice that is. If you're like using your Finder, like on macOS, like if you come back to it, it still like has the same window open, the same scroll position, the same thing selected. But if you're going to like any sort of web app and you just like reload, it has forgotten everything about your app. So this is another benefit that you get by moving the state of your app outside, handle that separately, and use a more powerful state management system for that. So that is one thing. And that as a sort of like consequence means there's like two reactivity systems now for your front-end app. One is the React View reactivity system, and the other is your state reactivity system. And now you need to bind those together. Sounds like more work, but it actually makes everything a lot easier. So that's take number one, move your state outside of React, and that makes things better. The other is like try to keep your re-renders under control. I did like a Twitter poll about this a while back, where I thought like, okay, the answer is going to be very clear. Most people are going to care as much about re-renders as me, since otherwise, how would you find like a problem in your React app if something doesn't go right? Turns out the majority just like doesn't give a damn about React re-renders at all, and that was really confusing to me. Since like if you can't understand how your React app is working, if everything is going well, and like just by initially rendering your app, by initially loading your app, and your app is already re-rendered 20 times, and you move your mouse a bit, and it has done another 15 re-renders. And that's like if everything is going well. But if you now have like a problem somewhere, and then it's really like looking for the needle in the haystack here. So this was my other ones. Like if we are more minded about re-renders, then everything gets a lot easier. However, with React over the last couple of years moving more towards like server-side rendering and React suspense, this has become a lot harder. And this is something that's also I keep wondering, okay, how long should I still use React, or rather moves towards something like Solid, as this is where React makes building high performance client side apps much, much harder over time, in my experience, by shifting those trade offs by letting React also run on the server. And this is where, if you actually want to have it simpler, let React just do less, move that state management outside of React. And like that also reduces the number of re-renders significantly. The by definition, almost like when React should re-render is when your state changes. And if you have better control over your state, then you can also have much better control of like how React is re-rendering. And the last one I will say is also on the distributed systems aspect in React apps. We're so used to like async await in our React apps, or whether that's hidden in a hook where you have a loading state. Now, again, you have a distributed systems in your frontend app, and now you need to coordinate that. That leads to loading spinners, etc. So if you can use a synchronous state management system locally, where you just can sidestep all of those loading spinners, makes your app faster, makes your app simpler. And that's another key aspect of Riffle.
Yeah, I think the performance point isn't really felt if you're like a medium size app and lower. But like, for example, on Descript, like we might not have felt those performance woes until like recently. But now that we have this like super complex app with a lot of state, like those re-renders bite us really hard. Like, for example, when you hover over our script, that was causing a re-render because it updates the state to say what thing is hovered so other things can highlight. And just like, it's so easy to like just fall into a very big pit of failure where it's like everything just starts to feel bad.
Exactly. And like getting out there is like, it's not easy if you've made the wrong assumptions.
Yeah, I mean, a lot of this is too. It's like after the transition to hooks, you've had to do a lot more manual memoization and like kind of understanding. Oh, there's all these like foot guns. It's like you didn't add this thing and this dependency in this array, and now it like causes an unintentional re-render or whatever. And I mean, that's hard. Maybe React Forget or the React compiler will help in some of this and make it a little bit easier to get some performance out of the box. But yeah, I mean, it's definitely a challenge. So before we move to tooltips, we always like to ask one future-facing question of our guests. And so given that you're sort of really steeped in the local first world, do you think local first is going to be kind of become more of the future of like how we develop apps, or it's like there's going to be more of a trend of like moving towards local first as kind of a de facto approach? Or do you think server-side apps or the traditional sort of app architecture will still reign supreme for years to come?
As like the most popular answer in computer science, it depends. And I think rightly so. And I think we've actually said it depends too little over the last decade, where we've just used like the traditional web server-side hammer for everything. And this is where like some web apps feel the way they do. I don't think we should now overreact and rebuild everything with local first. I think we should, in the cases where it matters, build apps with local first. I think for many apps it can totally make sense, and I think what will speak most credibly to the potential of local first and why it's worth it is that I think already the best apps, the favorite apps we're using on a daily basis, whether it's something like Linear or Superhuman or some of those Apple apps, they're all local first already. And if you're now a founder or like a product creator and you're thinking about like, okay, I do value high performance, or I do value speed. It might not even be that you want your app to work offline, but if you want your app to be collaborative, if you want your app to be fast, then the easiest way to do that is by building it in a local first way. And I think that will just naturally lead people to doing that. If you want to build an MVP very, very quickly that you like ship on Vercel for like a little SaaS thing, I think that's also totally fair. I think it's just really cool that we have another way to build apps that can also become like a viable path and a viable alternative. And I think then hopefully we'll see a similar investment into tools that we've seen like in the traditional cloud-oriented way, also with local first, and app developers have more choice.
Yeah, it's exciting to see. The apps that have gone local first have been just like wildly popular, like Obsidian and Linear. Like that type of experience is like a novel experience, and I hope I see more apps move in that direction.
Yeah, and I think that the thing I'm most excited about is like I think we'll hit a threshold at some point where it's going to be much easier for app developers to build apps this way compared to the way how we do it right now.
That was a big thing of the linear development experience, is like the product engineers who are working on the front end of it, they just like write to a local data store and they don't think about the API connection at all. They just like have these models and they write to the models, and that does what it needs to do with the API. And that, I think we have seen over time this collapse of like, previously we'd always had to build APIs for everything, right? Oh, we have to have an API for our app or whatever. And there's a lot of complexity that goes in that communication layer, going back to your distributed systems. And now it's like collapsing down and down and down. It's like, we want to focus on this little tiny thing that we're doing, and we only want to think about this.
Exactly. And this is really like if I had 2 weeks of time before, and I would spend 1 week on working on Overtone on the server and 1 week on the front end. Now I can spend 2 weeks working on the front end. That's what users use. And there's like no catch here. So it's really, it's less work that you need to do.
Cool. With that, let's move on to tooltips. So my first tooltip of the week is a TypeScript documentation generator. These have been around for a while, and I haven't really used them all that much because they produce really ugly docs, and I like my docs to be a little more focused. But for the thing I'm developing, it has a very large, complex API that I want documented both in code and on a website. And what's really cool about TypeDoc, it's your normal like give it an index somewhere and it'll go and show you all the exports and all the methods. The thing that I really like about it is the point that it's extensible. A lot of the times with these things, it's like you can generate a thing and then you get what you get, and there's like no recourse to make it better. But with their plugins, you have basically full control over what's generated. And with a plugin, you can be like, okay, a signature for a function was declared. Here's an event handler for that. I can get the type. And then if I want to, I can go resolve the type in a more like a better way for consumers to take it in. So one example of that is there's a Zod plugin. With the Zod plugin, instead of getting like Zod.infer with a type and it's this like generic thing, it'll actually go and get you the real type, the thing that is like the resulting type, the thing that you would want to see as like a consumer of the app. And like for my use case, I've been able to make it do whatever I want, which has not been the case with a lot of other TypeScript documentation generators. So if you're looking for something like this, really cool. So like you can go from 0 to a type doc generated website in literally like 5 minutes. So if you wanted a tool like this, nice, definitely go check it out.
That is super cool. I didn't plan to bring it up, but I was going quite deep on that rabbit hole also at the beginning of my sabbatical, where I was where TypeDoc wasn't as far along back then, and it also was annoying for me that the burden is on the library developer, library maintainer to set up TypeDoc and do all of that, as opposed to in Rust or Go, where you just have canonical docs automatically generated. And so I wanted to bring that paradigm to TypeScript. And I was working for a while on this project called Paka, where you can basically just go to paka.dev, like put in like your npm package name and you get automatically like reference docs generated. Turns out that's a really hard problem, and I had to basically, with a friend, had to kind of re-implement parts of the TypeScript compiler to really understand all the parts of TypeScript. So we got somewhat far with it, but never really launched. So it's somewhere in the past of like my interesting projects I worked on in the past.
Yeah, I think it would be hard to do like a tool like that that's like generates good docs for everything. Cause like I said, like sometimes you might have a generic thing that makes no sense and you kind of have to like manipulate a little bit into a better thing. Lots of power there, but also some hard edges for sure.
Oh yeah, that's what killed the project eventually.
So next up we have unstorage.
So key value stores are really important. They underline relational databases, and you pretty much anytime you're working in a project, you find the need for a key value store. I really love like Dino's key value store, but you can't use it everywhere. And I've been sort of on the hunt for like, I want a pretty adaptable KV solution where I can just like use it in any context. And, there are like a few specific things that I want. And there are a lot of KV service providers out there. So like Cloudflare has a KV solution, Dino has a KV solution, et cetera, et cetera. Anyway, so I saw a tweet this week that introduced me to this project called Unstorage. It's part of the Un.js, broader umbrella. And it's a sort of generic wrapper around a KV interface that can persist to a bunch of different targets. So you could have something that's like potentially going in local storage and going to like Dino KV or like Cloudflare KV or something like that. It's just really interesting. There's like one of the things that I like that you can do is you can specify like, oh, this key is persisted here with this technology and like other keys are persisted somewhere else. So you can like compose different stores into a single interface, which is really cool. I think that this is like probably something that, a lot of folks who are doing local first could benefit from, because you could do sort of local storage in some aspects and then remote storage in others. And the transportation or the API is kind of seamless in between them. So really cool technology. I'm excited to explore it more.
Yeah, seems useful. Next up, we have Nix.
All right. So my pick is Nix. I think this was probably already picked by a few previous guests. At least I hope so. It's a bit of an acquired taste. I've been hearing about it for quite a while in the past, and I've always like thought, okay, well, at some point I'll learn it. And since it is quite a bit to get into, but it's very, very powerful once you've learned it. And so the tipping point for me when I started to get into it is like where I basically, my README was starting to grow and grow and grow of like, oh, brew install this, brew install that, and like make sure that you have like this specific version of like GCC for this project, or the more like native tool chains you needed for a project, whether it's like for a like a native script or like for Tauri, or wherever you build like wherever you need something that goes beyond npm install. This is where I just was tired of like that it worked on my machine but not for someone else, and I didn't want to tell them like, oh, just like develop in Docker. And the best thing that really solves that is Nix, where you can think about it like a package JSON, that instead of like installing a package that's then available for your project, you can install like Node.js itself or Golang or like whatever you need, or Watchman or whatever you really need for your project. You can just put like into one flake.nix file. And then if you combine it with a thing called direnv, which just sources your environment variables, etc., when you cd into a directory, then like everything is just there. So I don't even have brew installed anymore on my Mac. And the cool thing is like that thing works across operating systems. Well, at least on Unix-based operating systems, so on Mac and on Linux, etc. And that's just like once you got into it, it's phenomenal, and you start using it for everything. And I'm even going as far as also provisioning my Mac and like other machines with us. I'm using this for running a smart home system on a Raspberry Pi, using this for my MacBook. I'm using this for a development server. I know, for example, that Mitchell Hashimoto is also using that for all of his dev setup. So I think more people should take the leap, learn a little bit about it. It's gotten a lot better to get started with. And then you don't need Brew anymore. You don't need like crazy Python hacks to get something to work. And like once you rewire your brain, it's really nice.
That's super cool. So like for me in my npm terms, it's like instead of installing everything globally, I'm just installing it like locally to the folder that I'm working in.
Exactly.
Nice.
I could see how that is very useful. I hate setting up global tools on my system.
Also, like the same analogy holds. Like, let's say you need to run like a one-off task for preparing a video. You can then just write nix shell ffmpeg, and even if you don't have ffmpeg on your machine, it's then just available in your shell, and you can use it. And afterwards, you can forget about it again.
Okay, my next thing that I'm sharing came up on my feed this morning, and it is wild. A dude, while he was in college, made a mini spot bot, like those big four-legged robots that can walk around. He made one with like an Arduino and a Raspberry Pi, and it started out as like a build your own little project, but now they've created ones that you can buy. So they have one that's like a little cat and one that's like a little dog, and it just looks absolutely wild to see something that was like the bleeding edge of technology not just a few years ago reduced to something that I can like hold in my hand. And my mind just goes wild with like the possibilities to make this fun. Like I wouldn't want to load an LLM onto the big one, but onto the small one, it might be cute and not seem like the world's ending. So if you want a very fun weekend project and have ever wanted one of those four-legged robots, I would go check this one out. It's called OpenCat.
That's amazing. I love the internet.
I actually own one of these.
Oh, you do?
I do. Yeah, the wooden cat kit.
Nice. I don't know what I would program mine to do, but it looks like it would be a fun thing to program.
You have to assemble it and everything, so it's a fun little project.
Up next, we have React Print PDF.
Yeah, so I this came across my feed and Twitter this week too. So there's a company behind this. So there's a company called OneDoc who's essentially building a mechanism for generating documents like PDFs. So think like invoices or whatever in that way. And so they're using React to do it. I've seen a lot of other really cool React compiled libraries. I think of like React Inc., like letting you run React in the terminal. But this React Print PDF seems really novel. So for DevTools, we have to generate invoices for sponsors from time to time. I have a little CLI app that does that for me, but it would be interesting to be able to do it in React because you can do, a lot of customization with your own, branding and, make it really generative and then make it something that like, web developers could sort of understand because Lord knows PDF is not the most graceful format. So a pretty cool library. I'm not sure how tied it is to their commercial service, how much you can do yourself, but definitely something to keep an eye on.
Yeah, it's cool to see companies that are like Resend, where they're like, here's this open source library that does React for X, and then here's our platform that makes it easy to deliver to everybody. Super cool. And one of the superpowers of React that like I feel like people outside the React ecosystem don't quite grok, because it's like you're not just learning to write web apps, you're learning to just write apps, and then your apps can be anywhere, which is such a cool idea. Then last up, we have the combo of @test and Perfecto UI.
All right. So a little anecdote on that. At the beginning of this week, I noticed that my VS Code has become really, really slow when I'm typing. When I'm typing a TypeScript file, and I noticed that this like over time just really degraded, where the autocomplete would initially be instant and then over time would just like become like half a second, 1 second. And I think it was at a point where it like took like 8 seconds or so. And it's like absolutely not bearable to work with this anymore. So I had to figure out like, hey, what is going on? And so I'm used to this kind of thing typically when running your app and your app is slow and like you start looking into performance profiles, etc., and you realize, okay, this is the bottleneck, and you make it faster. But now I'm basically trying to do that for VS Code. But more specifically, I'm needing to do this now for TypeScript, since the TypeScript LSP is running that. So a friend of mine who's working on that thing called Archetype, which is like an alternative to Zod, etc., really interesting to look into. But as part of this project, he's been building this thing called a test. And a test is basically like a type setup, like a testing setup, but for your types, where you can check like, hey, is the type correct, and how, and also on the performance level of the types, that you can see like, okay, for that type to infer correctly, this is doing like so much work, like instantiations, etc. So, and that project also comes with a CLI, which you can point at a folder of TypeScript files, and it spits you out a trace JSON file that is basically a performance benchmark for your given TypeScript project that you can now throw into this Perfetto UI, which you can basically just upload a JSON trace file there, and then you get sort of like a Google Chrome chart where you can look into what is slow, and this is where you then can like step by step figure out like, okay, this file specifically at this line, I'm inferring this type. And turns out I found some things that I would have never expected that literally took TypeScript like 3 seconds to infer, and I had a few of those. And in this case, I could just slap an any on it, and it was fast again. And so whenever you feel frustrated with like, why is TypeScript getting slower and slower in VS Code, those are some interesting tools to look into.
Yeah, that's super cool. While developing design systems, I've run into this problem a lot, because you try to create a polymorphic component and then TypeScript's just like, that's too much for me. So having a tool that can point me to where that slowness is actually coming from is huge.
Yeah. Shout out to David from Archetype for showing me all of this. Very useful.
Yeah, that's awesome.
Cool. And that wraps it up for this week's Tooltips and this week's episode. Thanks for coming on, Johannes. This was a lot of fun. We covered a lot of ground here, and you seem to be doing some pretty cool work right now.
Thank you so much for having me. This was a ton of fun.
Yeah, it's a really fun to have an episode crossover. I was just like listening to one of your episodes earlier. So it's like, but yeah, I mean, really love your podcast too. So keep up the good work there. And yeah, thanks for coming on.